Hello, welcome back to Algebra. We're working with Descartes' rule of sign. This is part 2. We've already learned what the actual theorem says. We have to find the variations in sign of the polynomial. We've learned how to do that. It tells us the positive roots are equal to the number of variations in sign or less than that number by an even number, which just means we have to count down by 2. And that gives us the number of positive roots. To figure out the possibilities for the negative roots, we do the same process, but we have to change the polynomial a little bit in order to figure out how many possible negative roots we have. We've done that in the last lesson. So here we're going to take a look at this quite simple problem, actually. It's a fourth degree polynomial. Here's x to the fourth plus 3x squared minus 4, and that's going to equal 0. And we want to figure out for all of these problems, list the possibilities of the roots, right? The possibilities. So we have to figure out variation in sign here. So there's no variation there. It's positive to positive. Here's positive to negative. So we have only one variation in sign. So because we only have one variation in sign for this polynomial, then the number of positive roots can only equal 1. Now, the theorem says it can be 1 or less than this by an even number, but you can't go down by 2 because then you'd have a negative number of real roots, and that's not the case. So you can't have that. So you basically, when you get down below 0, you stop. So really, there can only be one positive root for this guy. Now, in order to figure out the number of negative roots, we have to modify the polynomial like we did in the last lesson by substituting negative x in here. So what we're going to do is we're going to say this polynomial with negative x substituted inside is going to be negative x quantity, always put it in parentheses, to the fourth power, plus 3 negative x, negative x quantity squared minus 4. So this is the modified version when we substitute negative x. So let's do the simplification here. This is an even power, so the negative ends up multiplying to make it positive x to the fourth. Then this one here, it's squared, so it's going to be the same sort of thing. It's going to be 3x squared. It's an even power, so the negative sign just goes away. And then we have negative 4, minus 4. So we have no variation in sign across here, and then we have a 1 variation in sign from here to here. So because we have changed the polynomial to the negative x version of it, and we have 1 variation of sign, the number of negative roots has to equal 1, or less than this by an even number, but again, we can't count down any further. So in the previous lesson, we did a more complicated problem where we had so many different possibilities. But in this case, we only have one possibility for the number of positive roots, and also only one possibility for the number of negative roots. So there's no complex table to really build. Well, you can still build the table, but it's going to be one